In section 3, we're solving for radical equations. So to solve a radical equation, you have to get the radical alone on one side of the equal sign. So in this first example, first thing that we would want to do is get this square root of 3x over 5 alone, which means simply adding 8. And that would give us 6. In order to get rid of our square root, we'd be squaring. So 3x over 5 would equal 36. And now all that we're really doing is finishing off our question. Multiply both sides by 5. That would cancel off the 5s. There we go. And 36 by 5 would be 180. Divide by the 3. And x would be 60. If we go back and check, I know that the question doesn't really say anything about it, but we're just going to do it just for shoots and giggles. Negative 8 plus 3 times by 60 over 5. Does that equal negative 2? So 3 times 60 is 180. 180 divided by 5 should be 36. So we have negative 8 plus the square root of 36. Now this does technically go two ways, because the square root of 36 could be technically a positive or a negative 6. But when we are taking this square root, we concern ourselves with the principal square root, which really means we just kind of only worry about the positive square root. So then our question becomes negative 8 plus the square root of 36, which is just 6. And yeah, negative 8 plus 6 is definitely negative 2. We talk about our restrictions. Well, we have to think about what kind of numbers are we able to take the square root of. We can take the square root of positive numbers, and we can take the square root of 0. But we cannot take the square root of negative numbers, which means our restrictions, sorry, we don't need that square root, but all we need to worry about is what's underneath the square root, the radicand. We just have to say that it has to be greater than or equal to 0. And then by multiplying by 5 and dividing by 3, I'll make that actually look like a 3, or multiplying by 5/3, our restriction is just that x has to be greater than or equal to 0. Again, the reason for this restriction is we just can't take the square roots of anything that's negative. So we just have to say that our radicand has to be greater than or equal to 0. In a question like this one, we do the exact same kind of procedure. Get the radical all by itself. So I can add the 1. Get the square root of 3x plus 4. Make that actually look like a 5. Square, because squaring and square rooting get rid of each other. So that completely canceled up with that. And we'd be only left with a 3x plus 4 equals 25. Subtract 4. 3x equals 21. divide by 3, and x equals 7. Sorry, let's probably put this in our solution set as well. If we go ahead and check, -1 plus the square root of 3 times 7 plus 4, does that equal 4? 3 times 7 is 21, add 4 is 25. So -1 plus the square root of 25. Yep. There we go. It does equal 4. Our restrictions is, once again, we have to just make sure that our radicand has to be greater than or equal to 0. Because we can have this equal to 0. Just like we could plug 0 into here, and square root of 3 times 0 times divided by 5, square root of 0 is 0. It's not our solution, but it's just saying that our answers have to be greater than 0. I'll explain that a little bit better here. We have to just say that 3x plus 4 has to be greater than and or equal to 0. So by subtracting 4 and dividing by 3, the x has to be greater than or equal to a -4/3. And that is absolutely the case. Our x answer, well, our actual solution is 7. It's definitely greater than -4/3. Last example on this page. A little bit trickier. So there's multiple ways of doing it. And some of you will do it one way, some of you will do it the other. I'm just going to subtract an x. But subtracting an x, I'm still going to have that negative in front of that radical. In order for me to get rid of that negative, I then have to divide by -1. So I'd have the square root of 2x plus 3. Dividing all this by -1 means basically our signs change, or our negative x divided by x is x, and our positive 6 divided by -1, sorry, negative x divided by -1 is x, and positive 6 divided by -1 is -6. This question is going to make it a little more difficult, because we are going to be squaring an x subtract 6. Squaring this side, we're just going to be left with that 2x plus 3. But on this side, we are going to be multiplying both sides, or sorry, this entire side twice. So x subtract 6 multiplied by x subtract 6. Distribute to give us that. And finishing off, because we have an x squared, we're going to have to get one side equals 0 in order to solve. So subtract the 2x, subtract the 3, and let's see, -12, -14, plus 33. So a product of 33 and a sum of -14. That would be an x subtract 11 and an x subtract 3, which means setting each of these equal to 0, again, just nice kind of reminder, equals 0, equals 0, x equals 11, x equals 3. So we potentially have two answers. In order for us to know, we're going to have to check them. I think that what I really need to do in this is actually say solve, check, and state restriction. Yeah. So we're going to check the 11 first. So 11 subtracting the square root of 2 times 11, add 3. So 2 times 11 is 22, add 3 is 25. So 11 subtract the square root of 25. Square root of 25 is 5. 11 subtract 5. Yep, that equals 6. So that one's good. What about 3? 3 subtract the square root of 2, and I'm going to have to erase that. 2 times 3 plus 3, so 2 times 3 is 6, add 3 is 9, so 3 subtracting the square root of 9. Square root of 9 is 3. Does that equal 6? No, it definitely doesn't. So the reason why we're getting two answers here of 11 and 3 is for the simple fact that the square root of 9, yeah, we could technically be treating it as the positive or negative. But when we were solving all this, we actually got rid of that square root, which with that squaring, which means we are still only going to be dealing with that principal square root, the positive square root. Meaning our only answer is 11. Sometimes our restriction helps with this, sometimes it doesn't. But what we have to concern ourselves with is that 2x plus 3 does have to be greater than or equal to 0. Solving for the x, we'd subtract the 3 and divide by 2. X would have to be greater than or equal to a negative 3/2. Well, both of these are bigger than negative 1/2, negative 1.5, but only one of our answers actually works out. Alrighty, let's take. All right, yeah, these ones are good. These ones are going to be a lot more difficult, but that's okay. Solve the following equations, state the restrictions, verify the answers. So I don't have that much room. All right. So this one, we have two different radicals. We have a y at 12 and a square root of y. My suggestion, sorry, actually, I should write it this way. Get the harder one alone. That's my recommendation, is get the harder one alone. So in this one, y add 12 is definitely harder than y. Just there's more to it. So to get it by itself, we would add 2 to both sides. And I'm just going to write over here just so I have enough room for everything. Y not x. So we're not adding the 2 inside there, it's being tacked on at the end. Now we're going to solve it kind of the same way that we're doing, just we're going to get this harder one, get the harder radical gone. By squaring this side, the square and the square root would simply cancel off. But on this side, we would have to actually be multiplying the two things together. Square root of y plus 2 multiplied by square root of y plus 2. So when we distribute, we'd have the square root of y multiplied by the square root of y, which comes out as the square root of y squared. Square root of y times positive 2 will be a 2 root y. 2 multiplied by root y would be another 2 root y. And 2 times 2 is 4. few good things to note. The square root of y squared is just y. Because y squared is y times y. Take that group of 2 out, and there's nothing left. Or you can realize that square root and square just cancel each other off. This one, yeah, we're going to have a little more work to do. Sorry. 2 root y, add 2 root y, it's 4 root y's. Now the good news is here, we only have one radical left. There's just that 1 root y. So we're going to get it by itself now, which means subtracting a 4 and subtracting a y. Those y's cancel off, and we're just going to be left with 8. So 4 root y. Get the radical by itself, which means that we'd have to divide by 4. And then our lives are way easier. We square both sides, and y equals 4. If we want to check or verify, we plug it back into the original question. So square root of 4 add 12, subtract 2, square root of 4. No, square root of 16. I'm just going to skip a step. That's 4. Subtract 2. Does that equal 2? Absolutely. So our solution is 4. Our restrictions, though, are going to be a little bit trickier. What we're going to have to consider is both of these. Y at 12 has to be greater than or equal to 0, and just y has to be greater than or equal to 0. So this one means that y would have to be greater than or equal to negative 12. So now we have 2 restrictions, but in reality we only have 1. If we think about a number line, we have negative 12 down here, and we have 0 up here. This one says that all of our answers have to be bigger than that negative 12. So we'd have all of those and going that way. And that's what this one is saying. This one is saying that all of our y's would have to be from 0 and bigger than it. Well, which one is right? The one that is correct is the one that actually has the overlap. There's no overlap of the 2 inequalities right here. This part is the only part that matters. Because if our y's have to be greater than or equal to 0, our y's being greater than or equal to negative 12, well, a number greater than or equal to negative 12 could be like negative 11. But I can plug negative 11 into this inequality, or this radical right here. Negative 11 plus 12 is 1, square root of 1. Okay, yeah, that one works. But I can't plug the square root of negative 11 into here. So this is the only restriction that matters. Hopefully that does help a little bit. Alrighty. Square root of x plus 3 add square root of 2x minus 1 equals 5. Get the harder one alone. Well, they both have something attached to it. So that this, personally, I think that this one looks a little bit harder. So let's get rid of this. Let's get rid of this square root of x plus 3. So we're going to have the square root 2x minus 1 equals a 5, subtract the square root of x plus 3. Doing this, getting one radical alone allows us to square. Now if I square on this side, root and square cancel off. I'm just going to be having that 2x minus 1. On this side, I square this side, it means I'm going to be distributing 5 subtract square root of x plus 3 onto a 5 minus square root of x plus 3. And then we properly distribute. So 5 by 5 is 25. 5 by negative root 3 plus root x plus 3 would be a negative 5 root x plus 3, and same thing on that one. Negative root x plus 3 multiplied by negative root x plus 3, oh, forgot my other bracket there, will be a positive square root. X plus 3 times x plus 3 is, the quickest way of writing it would just be x plus 3 squared. So that our next bit of work is that square root and that square actually cancel off. So combining all the things that we can, we have a 25, negative 5 and negative 5 root of x plus 3 would be a negative 10 root x plus 3 plus an x plus 3. Now we can get one side equals 0, and, or more specifically, try and get this radical all alone. To do that, I would subtract a 25, subtract a 3, and subtract an x. So I'm going to have an x, negative 1 subtracting 25 is negative 26. So negative 29. Oh, sorry. Then we have a negative 10 root x plus 3. So now we're getting into more complicated stuff. Absolutely, one way we can do it is dividing both sides by the negative 10. We can do that. I'm going to show you another method. I'm actually going to square both sides right here. By doing this, we have an x minus 29 squared, which means it'd be an x minus 29 multiplied by an x minus 29. Distributing everything out, we'd have an x squared minus 58x. And 29 squared, or 29 times 29, would be a 841. On the right-hand side, squaring this one, because it's all actually one term, we're not going to, well, there's two ways of dealing with it. First way would be distributing the squared onto there and onto there, or just treating it as another negative 10 root x plus 3. So at our negative 10 times negative 10, or negative 10 squared, is 100 multiplied by root of x plus 3 times root of x plus 3. Well, that'd be an x plus 3 squared. Just like over here, I'm just going to have 100 multiplied by x plus 3. Yes, this is for sure one of our more difficult ones, just because there's a lot more work to do with it. But it doesn't hurt to do harder ones in our notes, so that when you do assignments, they're actually nice. I'm distributing my 100 in. And then I can get my one side equal to 0. So I subtract my 100x and subtract the 300. So x squared subtracting 158x plus 541. Oh, so a product of 541 and a sum of negative 158. Can we do that? The answer is no, we can't actually factor this nicely. Well, if we can't factor, we can certainly use our quadratic formula. So negative b, which would be 158, plus or minus the square root of 158 squared, multiplied or subtracting 4 times 1 times 541 all over 2a. So we'd have 158 plus or minus the square root 158 squared minus 4 times 1 times 541. We're not going to worry about simplifying these because we just want to find out our solutions, which means we just want to get straight to our answers as fast as possible. 158 adding the square root of 22,800 divided by 2. We'll round one decimal place on this case, and subtracting it, divided by 2, we get 3.5. We're not going to worry about checking these ones. Oh, sorry, we'll just kind of visually check. Square root of 154.5 plus 3, so square root of 157.5 is going to be a much bigger number. So we already know that square root of 144 is 12. So 157.5 is going to be it's going to be bigger than 12. 2 times 154.5, that's 309. Subtract 1, 308. Square root of 308. Well, you're looking at over 17. So 12 plus 17 is 29. That's never going to give you 5. So this one's definitely out of the question. But the square root of 6.5 is 2.55. Square root of, let's say 2 times is another 7. 3.5. Yeah. No, 6. Yeah, 6. Is 2.45. Yeah, that's 5. So our only answer here is that 3.5. Keep in mind, I will probably be changing this example for next year, but it's a good one to see. Looks like fun. Alrighty, final thing, just talk about our restrictions here. Our two things have to be greater than or equal to 0. So this one, our x's have to be greater than or equal to -3. And in this one, our x's will have to be greater than or equal to 1/2. The one with the overlap is this one. This is the only restriction we care about. Because if I plug 0 in, which is not greater than 1/2, but it is greater than -3, I plug 0 into this one as a square root of -1. And in our current math, we can't do that. In other maths, current Saskatchewan curriculum doesn't have it, but it is imaginary numbers. Yeah, literally imaginary. Okay. So nice word problem just to finish it off. Josh is shipping several small musical instruments in a cube-shaped box, including a drumstick which fits diagonally in the box. Determine the formula for the length d in centimeters of the drumstick in terms of the area a in square centimeters of one face of the box. What is the area of one face cube-shaped box that holds a drumstick of length 23.3 centimeters? Express the answer to the nearest square centimeter. So there's a few things to note about this one. First off, we have a box. Inside that box, so if I actually finish off my diagram a little bit, and I'll make that nice. We have a drumstick. It fits diagonally in this box. Okay. It is cubes. Sorry, make sure we clearly identify this. This is a cube, and our drumstick would fit completely diagonally in here. So this is a little bit more difficult. We're going to have to do a little bit of calculation to it. Actually, what I'm going to do is I'm actually going to make this a little bit bigger. So we're going to have a box like so. Make this look a little bit nicer. Okay, so what we're looking at is we're looking at a cube-shaped box, which means every single one of our sides are the exact same length. What we're looking at is we're looking at trying to find something that goes from this corner, like bottom left, front left, to the back right. Well, we know a few things, actually. We know about what this diagonal on the bottom would be. And what this would be. So the first thing we know is with the cube, all of these sides are the exact same length. So we can call them, well, let's call them x. We don't know exactly what those diagonals are, but with using our Pythagorean theorem, that side, let's call it, I'll use G for green. That Pythagorean theorem states that hypotenuse squared would equal x squared plus x squared, the a squared and b squared, because this would be a right angle triangle. Similarly, if we already know that that is x squared plus x squared, our red, so we'll call it red squared would be g squared plus this x squared. Well, since g squared is already x squared plus x squared, r squared would actually be x squared plus another x squared. So r squared would equal 3 x squareds. 1, 2, 3. Since we already know exactly what that length is, 23.3, we can finish off the rest of our work. So our radius, the red length, sorry, not radius, sorry, 23.3 equal a 3x squared. 23.3 squared is 542.89 divided by 3. 3. So x squared would equal I guess we're just asking for what's the area of one side. So well, let's just change the question. What's the side length? There, sorry. What is the side length? Answer the nearest tenth of a centimeter. We're not determining the formula. I'll just reword this for next year. So 542, we get 100 divided by 3, what would be 180.96 and 3 repeated. Take the square root. And it would be a 13.5 centimeter dimension box. Bit of fun. These are your questions for practice. So, have some fun. See you soon.